Hi everyone, welcome back to the TamTech Academy Chemical Engineering channel. Today we'll be talking about one of the key topics in process and mechanical rotating equipment engineering. In one of the case study explanation, we have combined actually multi-stage compression and some basic principles from the separation. During the case study, you will find some controls from the separation and also some problems in the compressors. That's why what we told you at the beginning that this is a combination of the process and mechanical, a bit also rotating equipment engineering. So what I recommend you at the beginning, so during the case study period, I'll give you the description, and after description, you can stop the video at least for 4 to 5 minutes for brainstorming. Right after that, so you can continue to watch and check your answers with our solutions. If you are ready, let's get through with that. So, as a tip and also hint at the beginning, so for the case study, we'll go through a basic scheme of the multi-stage compression and then discuss two practical troubleshooting cases that often happen in gas processing plants and in most of the chemical processing plants. So in the case study, let me show you the description. This is the description of the problem. First of all, you have an absorption column or any other type of the separation equipment like a scrubber or flash drum, knockout drum, that doesn't matter, or maybe horizontal separator or vertical separator, but this is the separator. So what I have added here is the absorption column, and from the top of the absorption column you have the clean gas leaving the column. So this clean gas, it will be going through the multi-stage compression. In the first question, it is asked to complete drawing and scheme of multi-stage compression unit, and you have like the 1 to 2 minutes to complete this actually during your the answer. However, we have two important cases. Like it's more about the troubleshooting and also the some analytical skills required to complete this part. In the second case, that discuss two cases. The first one, compressor has huge vibrations and you need to think about the root causes, and as an engineer, how would you solve this issue? In the second case, so from the field data, the operator told you that you should be checking your liquid level trends in the column because he observed that in the past 1 month or 2 months, let's say, the liquid level is getting decreased and you don't see any buildup actually in the column. And also imagine that, so after this column, you should have the compressor because as it's seen from the name, this is the multi-stage compression and you should have the compressors, okay? So that's why in both cases, you should be thinking about the compressor. And please mainly focus on the process type of the, let's say, the upsets, the fluctuations, because we also might have the different, let's say, the answers from the mechanical and rotating, but today we'll be mainly focusing on the only process ones. So you need to think about these cases, and in both of them you should be thinking about the consequences, root causes, and how would you solve it as an engineer. Please use your analytical thinking skills, and you should be able to complete it in 5 minutes. Now you can stop the video, and after completing it, we can start discussing. Okay, so let's continue and see what is the multi-stage compression. Before going into the directly the solution, I'll give you some basic explanations. Then you'll be able to understand, so why do we need this equipment, why do we need this kind of the stage compressions, and etc. First of all, remember that in every plant, if you have the, let's say, the gas processing, so you should have the compressors because the compressors are used to transport the gas or increase its pressure. For the liquid, we always tell that, so this is mainly the pumps. So you should be careful with this. So if you have the gas in the system, you should be using the compressors. If you want to use only one compressor to increase the pressure, let's say from the 5 bar to 100 bars or 5 bar to 50 bars, you should need like a very big compressors. And the very big compressors have additionally like the mechanical issues, rotating equipment issues, and also some process related issues. That's why it's highly recommended to do in the stage version and you can use and do some controls on each stage, like the compressors from the first stage, second stage, third stage, and etc. There are so many drawings and also PFDs, PNIDs available for multi-stage compression, and also at the field you can see this stage compressor types. But today I have added one reference from the design dynamic modeling from the CO2 compression system. You can find the link here and also be able to read this article. It's really interesting and definitely related to the chemical engineering. So first of all, let's see the our diagram here. So as you can see, this is stage type of the compressor. How you're starting, you have the flash drum, any type of the separating equipment like a two-phase flash drum. So it is based on the pressure decreasing principle. You are trying to flash down the liquid heavy part, and from the upper part, from the overhead, you have the gas. So this gas will be sent to the first stage compression. As you can see, it will be increasing its pressure a bit. Let's say 5 to the 20 bar. It's just a random value and figure. So you'll be able to increase it, like let's say the 20 bar, and your gas temperature will be also the increasing due to its thermodynamics. Okay. And after you have this hot gas at the outlet of the compressors, it is not recommended at all to send it directly to the second stage compression, because the hot gas could, let's say, then do some wirings, do some loosening inside of this rotating machine. That's why it's required to do like the interstage cooling. So it is written mainly the cooler, but we call it mainly the interstage cooler. I hope it is clear. Next, interstage cooler is used, and you will be able to decrease the temperature of the hot gas after the first stage of compression. So after having the let's say desired temperature, you will be able to send it to flash drum again. So you should be asking the question yourself. So why do I need like this multi-stage compression? Why do I need multi-stage interstage cooler? And why do I need in each step, after each, like let's say the cooler, these flash drums or scrubbers or knockout drums? There are so many names called for this separator equipment. The reason is that as you have cooled down your gas, you might have some water droplets, water condensate inside this column, and the liquid droplets could be wearing as well your rotating machinery. That's why you should be separating these liquid droplets in the separator. So the flash drum, it's used in after each cooler in order to separate these liquid droplets. As you can see in this example, this is just the water, and from the overhead you have the CO2, but in the refinery, in the upstream, downstream facilities, it might be a different content as well. But this is a basic scheme, and also as I said, the theory and background is literally the same for the all type of the PNIDs, PFDs, and also the content, gas content. So after flash drum, you send it again the stage to compressor, then cool down, then again separation, then again compression, then cool down, separation. It is the same mechanism for all stage compressors. It depends on how much pressure you need at the end of the process and how much time you need to increase in each stage compression. I have added here actually like the sequence of the process. Start with flash drum initial separating equipment. In our case study, as you have seen, it is absorption column or just a vertical separator. Then you have first stage compressor, interstage cooler, flash drum, knockout drum, scrubber. You can take notes here. Then second stage compressor, interstage cooler. The same sequence is like continuing till the end. And one more recommendation here, you need to be able to answer this question. So why do you need stage compression? Why do you need interstage cooling? And also, why do you need the flash drums after each stage? I hope it's clear, because it's like the heart of the process. And if you don't understand this part, so you shouldn't be like completing the case studies as well. I hope it's clear. And now we'll go to the case study part. In the case study, I'll discuss the first part especially. So it was asked to find out why your compressor has the huge vibrations. The compressor, which I told you, it's in the previous presentation. It doesn't matter first stage, second stage, third stage, just the compressor, let's say, the PFD, let's say the symbol I have added here. So this compressor has huge vibrations. We need to find out why do we have this like really huge vibrations that and in order to find out what could be the potential reasons, it actually indicates that it might be mechanical, hydraulic, or process related problems. As I mentioned at the beginning, so we might have this rotating mechanical as well, more issues from their side, but in this part I'll mainly discuss with you only the process detailed ones. So this is one of the most critical issues, by the way, in the gas processing plant, like having the huge vibrations. So that's why, so let's start with, for example, process fluctuations. So what process fluctuations means that, so you might have the surge conditions or liquid carryover from the upstream separator. As I told you, before this compressor, I had vertical separator, and from this vertical separator, from the gas, from the upper part, you had the gas going through these compressors. Okay, it says that, so you might have the issues with this absorption column, this vertical separator. That's why you have the issue with the vibration in the compressor. Or I'll give you one more example from the mechanical part, like mechanical imbalance, or let's say the resonance issues. Like it might be due to the worn bearings or misalignment, unbalanced rotor inside the compressor, or what I told you about the resonance, it might be caused by piping layout, natural frequency, and etc. And how would you troubleshoot? How would you start to solve this issue? You can start with checking your vibration data trends. Actually, the mechanical engineers, the also vibration engineers will help you with that. So the vibration data should be checked with the manufacturer limits, and also you can ask for advice from the manufacturers as well, manufacturer and company, why you have this type of the issues. But this is mainly mechanical and rotating equipment part. But if you want to do this process related things, process calculations, you should be focusing on the surge condition and the liquid carryover. So, and if you detect that you have the surge condition already, surge is suspected, so you can do some review on the anti-surge control systems, which is always available like on the compressors. And now I will explain you what is the liquid carryover, what is the surge condition, and why it actually can cause a vibration. You can find that there is one important keyword, which is the slugging. So slugging is the flow regime in general, and you don't have only the slugging, you might have the tubular flow, annual flow, plug flow, and etc. That's why I recommend you to find out and watch some videos or read some content related to the different types of the flow. Especially for the compressors, we'll be discussing now the slugging flow. And as a hint, for the second case, we said that we don't have any liquid buildup. This time we'll also discuss that we might have some control issue in the separator. That's why we don't have the liquid buildup in the separator. So to understand this liquid carryover content, so I'll give you first of all this picture, which is horizontal separator. Actually, you can see this high liquid level and low liquid level. But in our case, the separator is the vertical. That's why I'll show you the vertical. However, this is the same mechanism. If you have the really high liquid level, if you are already at the design limit in terms of the separator, this is done actually during the sizing of the separators. So this is called high liquid level. If you have the really low liquid level and there is no buildup, no separation, let's say more gas, this is the low liquid level. So for the vertical separator, I have shown you already. This is the high, this is the low or high and low. So what I want to mention here, generally, if you have the high liquid level, which means, let me show you like this, high liquid level, it means that during the separator sizing, so you have mentioned, you have found out your the high liquid level, but during the operation already, you have more liquid content. And this is actually the, let's say the, in general, this part, the liquid, normal. This part was the gas area. For proper separation, you have the dedicated area for the gas and liquid particles. So in the case of your liquid level is more than the normal one, which is like at the high level, it means that liquid area is getting increased and build up like this. And it means that it takes out some part of the gas area as well. It doesn't allow the gas have the proper distribution. That's why it creates kind of the slug flow condition. So it takes out some gas particles with it takes out some, let's say, the gas particles with itself, and creating such flow cases. This is called slug flow. And what we mentioned at the beginning, that so from the top of the vertical separator we have this compressor. That's why if the gas area is decreased, you don't have proper separation, you might lose some liquid content into the gas. Therefore, gas will be going out from the separator with these liquid droplets. It starts with just the liquid droplets, but as the time passes, if you don't take any action before it is getting worse, so you will be facing more issues during the lifetime of the let's say the processing facility. Okay, that's why you should be taking the right actions before it's getting worsened. So the gas particles will take some the liquid droplets as well, and will go through to the compressor. As the compressor faces with these liquid droplets, its machinery is not designed for this liquid. Its thermodynamics background, it's only and only designed for the gas. That's why when it sees the liquid, so it cannot be able to transfer this energy of the liquid to the outlet. So therefore it starts to do like the huge vibrations, and you can hear this voice from the outside. So this is our recommendation to check from the process side, like the high liquid level if you are operating right there, or if you have any issues with the inlet liquid level and etc. So in the second case, which is the this time low liquid level, it means that this time you have more gas. So I'll use this color. You have this time more gas. Now it doesn't allow the proper distribution of the liquid droplets. That's why from the liquid outlet, liquid will be taking some gas as well with itself, and it will go to the downstream facilities. So we don't know this time what is located at the downstream of the separator, but if you have really critical equipment, for example like the pump or something different, so you might have the another consequences at the downstream. So this is not only, by the way, due to the low liquid level, but you might have the also issues with the control valves at the outlet of this liquid side from the bottom of the vertical separator. So you should be careful with these two cases. If you have the gas, so with the liquid droplets from the gas outlet, it is called liquid blow-by, liquid carryover. If you have the liquid entrained the gas inside the liquid due to vaporization, due to flow control issue, due to level control valve issue, and etc., it will be called gas carry under, or let's say the gas blow-by. I hope it's clear, these two main terms, and these are really useful for your technical English as well. And these are one of the most common, let's say, the critical issues in the separators. You should be very careful with your control system in the separator. So I have added these two simple terms, liquid carryover, gas blow-by, and gas carry under. Some reference book actually mentions it as the gas carry under. If you don't find the related content, you can search with this name. So, and I have taken these two control systems, let's say how it looks like from the GPSA book, from the section 7 separation equipment section. I highly recommend to read this book, and also especially this section, because it is coming from the in industry engineers, and there are really good examples to understand the basic principles of separation control systems and some troubleshooting cases and also examples. I hope it is clear, and if you need this book, at least this section, you can write or drop your Gmail in the comment section and we can send it to you via the email. Now coming to the case 2, the second part, we already discussed, but let's go through each part again. Liquid level in column decreasing over time. And operator, we said that reported that liquid level in the absorption column has been decreasing over the past months. And sometimes there is no liquid buildup at all. By the way, it is not only due to really bad cases like the low liquid level, high liquid level, level control valve issue, flow control valve issue. It might be also due to that you have perfect separation and you don't have any liquid at all. So it is also the case, but we try to find out some process related possible root causes. That's why we mainly discuss this time only the liquid level controls in the separators. But you need to be careful with that. So you might have the really perfect separation. That's why you don't have any liquid buildup in the your interstage flash drums, let's say. So the possible causes for us, we have listed some of them like reduced liquid level, increased vapor load, or instrumentation error as well. It's actually one of the most common errors in the processing plants. And in order to make sure that before starting and analyzing the issues, so in the plant, you should be careful with that. So your instrumentation show correct readings. That's why first of all correct with this one, then you can start to discuss and analyze that your liquid vapor feed reduction and also vapor load increase. Consequences: poor gas liquid contact. It means that your separation efficiency will reduce. The gas might enter the compressor with entrant liquid, potential compressor damage again, overheating of spec quality downstream, and etc. How to solve it? First of all, as I said, start with level transmitter calibration, verify that it is correct, verify your column pressure and temperature. If you have higher pressure or higher temperature, you might have also vaporization inside the column. That's why your gas content area is getting increased and you have the lower liquid area. Then as a process engineer, you need to be like the simulating or doing some Excel calculations on the separator sizing to make sure that your outlet streams are correctly aligned and you don't have the gas blow by or gas carry under or liquid carryover cases. I hope it's clear, and we already like to discuss the all parts of the troubleshooting cases and also multi-stage compression. So in summary, I want to mention that so in multi-stage compression, good separation and proper operation between stages are really crucial, first. Secondly, high compressor vibrations often point to process upsets and also mechanical imbalance, rotating equipment machinery issues, and decreasing liquid levels in column can mean loss of feed, equipment malfunction, again process upset, instrumentation error, and etc. And we are, as an engineer, our job is to connect these symptoms, what we have already discussed here, to physical causes. Like you need to always be able to combine your data analysis, your site field checks, and your engineering judgment as well. So if you found it useful and also helpful, please don't forget to like, subscribe, and share this video with your other colleagues. Hopefully see you in the next case study and in the next lesson. Thank you. Have a good day.